Welcome to this Absolute Basics tutorial on using the BBC microbit. I recommend that you do some of the early steps that you're about to see whilst you're distributing the microbits around the class so that workstations have time to catch up, log in and do various other bits and pieces that may be required. So without further ado, we will get ourselves onto the BBC website. And inevitably on first access you are going to be faced with a request to confirm that you're okay with cookies, so the user will need to continue, and then so that it can load up the programming environment you can either click Create Code here or Create Code here. Either are identical. Presents you with the various different programming environments that are available. For an absolute basics session, I prefer to use the block editor as it's very Scratch-like. So we click New Project. And then that gets all loaded up. Now, if they by this stage have got their microbit in their hands, and you may want to go through some of the elements of the microbit, but it would be good to get them to plug it in. And you can see down here that there's just a little bit of device driver software to be set up. I haven't come across a workstation that hasn't been able to do all of this automatically in the background. However, your mileage may vary depending on your particular virtual network if you use Citrix or similar. And you can see that Windows Explorer is flashing away here because it's now recognized the microbit as a flash drive. We'll just move that to one side for now. You may wish to then introduce the students to the various different hardware functions, and there's facilities that are on the microbit, the 25 LEDs, the 2 push buttons, the reset button on the back, and the various different chips that are available. There is a separate video that covers that for you. As an absolute starting point, sort of the very basics, we go with basic, and then we will click show string, and you can sort of move it to wherever it suits you, and you could change it to your name, which very amusingly for my code clubbers, they actually put your name when I meant Nick. And if you press run, that will then show it on the simulator. So we can compile, which creates it for the microbit. The different versions of Internet Explorer and Edge may say different things, but effectively we need to save. And at this point we could either view downloads and then just click the download link and we can see it, or alternatively, if we just close those away, the other natural route is Windows Explorer, and then click on downloads. And programming or downloading it to the microbit is as simple as dragging and dropping it on. There will be a small delay whilst that copies over, and then the microbit will automatically eject itself, and then it will remount, so it just comes back. You can just click the close box, and then it will start displaying the string that the student has typed in here. If they wish to have it replay, then the reset button can be pressed. That's on the back of the microbit, and then that will run that again. And that is the starter for 10. If they want to change the name of the script, they could change it to my first script, and then they can go back into their list of scripts, so you can see my first script that we've got here, and they can move on to the next task. So if we create code and we use the block editor, That will take us back to where we were before. I'm going to use one of the different input blocks to trigger our script, the on button A pressed. Then we are going to get the microbit to display a number, and you can see how it sort of drops in and automatically expands, and you get that sort of little yellow that tells us that it is accepting it sort of jigsaw piece style. And then we can take one of the other input blocks. I'm going to use temperature, and we just drop that on again, jigsaw puzzle style, very scratch-like. And now we have a short script that when the button A, which is this button on the simulator, and matches up with the markings on the microbit itself, is pressed, it will then show a number, and it will take a reading from the CPU. So if I press run and then I click on A, because obviously it's on the computer as a simulation, it just comes up with 21 each time. But at this stage we can now compile, which then we can save, and we can then do the drag and drop. Each time you create a new script, you get sort of its name is some superlative, amazing, awesome, fascinating, marvelous, some such things. The best thing to do is for people to either keep an eye on how this matches up with the script name that's auto-generated with what's been downloaded, or the date modified, which will obviously sort of the latest one will be on there. So if I drag that over, it will then copy that file over to the microbit, which, as before, will auto eject itself. And then for it to work for the student, they will then need to press the button. It doesn't display ambient temperature, just a little bit above that. And if they sort of keep the unit cupped in their hand or place their hand over the back of the unit for a few seconds, they may well see that the temperature rises. So if we perhaps do a variation on what we've just done and try changing the input block to light level, and we can just drag out the temperature and replace it with light level. Not much mileage really in running this, as there's no way for it to actually sort of display the light level. So we'll just go straight to compile. We'll save that, and you can see that it says that microbit unique script brackets 1, because we've now downloaded two things with the same name. That we get the name again, but sort of an indexing number, and I can show you that if I just change close that away, get rid of light level, and use say running time in milliseconds, and when we compile that, well, I'd expect to see when I save it that it's incremented it again to number 2. And as before, it's just a case of dragging over the most recent file for the user to try it out. So once they've gone through the basics of just getting it to display their name, and then they've got up to the point where they can have it on button A pressed, and they understand the concept of the different input types that they could have the microbit display, they could run through a discovery session in their own time, and as well as those different input types, they could also sort of expand on it by having the microbit do something if a button B is pressed, and even going slightly further, with the internal accelerometer, it can respond to either being shaken or the screen being up or down, or the logo being up or down, depending on which way they hold the microbit. And there are a number of different items. The slightly more unusual one is the compass heading. If I just take that out of the way, where it has to be calibrated. It needs to be calibrated each time the microbit is programmed, or there's a download to it, and as such, microbit will prompt them to effectively move the flashing LED around to create a box, because that way it's experienced enough. As you can see there, it just goes and displays 0, but it's at that point experienced enough magnetic force that it then has a better idea which way north is, and is is remarkably sensitive, but entirely feasible to have the USB lead that's plugged in the top pointing at 0 degrees. And it's also quite an interesting discovery session for people to think about points of the compass and where things are laid out. So I've found in practice that depending on the group size and how cooperative they're feeling, that this is a good 45 minutes worth of activity, with the ending largely being a sort of self-run. As ever, the young ladies tend to be a little bit reluctant to just dive in and try things out. I've had a microbit now for 6 weeks. I'm an electronics engineer. I've done stuff to a microbit that I'm sure BBC never had in mind, and I still have 3 fully working ones. Obviously I haven't used a hammer or done anything silly, but I have tried all sorts of different aspects of the programming, and I've wired things up, and I've found it to be an entirely robust device. So it's certainly exploring different elements is absolutely fine at this level when you've not got anything connected to the outside world. And for those that are more familiar with, quite familiar with Scratch, they may find the variables and doing comparisons and calculations are something that they can just sort of pick up quite quickly. The notes for this are available to download as well, and if you've got any questions, just leave comments either on the YouTube video or actually on this web page, and I'm sure discussion and answers will be forthcoming. Thank you for watching.